A very good morning to all. Today we are going to discuss one of the important topic in your syllabus in physics itself. That is the laws of motion. Okay, so let's begin. You may have discussed or studied the important topic in physics, that is gravity. You may have discussed in the previous chapters what is gravity, how Sir Isaac Newton discovered gravity, that about the apple head, etc. You may have discussed. Okay, now we will discuss about the laws of motion or Newton's laws of motion. Okay, Newton presented three fundamental laws that govern the motion of objects known as Newton's law of motion. That is, there are three laws of motion. First one is Newton's first law of motion, Newton's second law of motion, and finally Newton's third law of motion. There are three basic laws. Okay, before going to that, we will discuss what is motion. You maybe know what is motion and all that. So, what is motion? If we are giving an effort or force to a particular object, that is, if we are giving a force or an effort to a particular object, that object will tend to move in the direction of application of that particular force. That movement is known as motion. Okay, that is if a body, consider a body, if we are applying an external force to that body, then the body will try or tend to move in the direction of application of that particular force. That movement is known as motion of that particular body. Okay, clear? So that's the basics. So now we will go to Newton's first law of motion. Okay, let's discuss what is Newton's first law of motion. Let us first discuss the statement. It states that an object remains in a state of rest or uniform motion in a straight line unless compelled to change that state by an applied force. That is, an object remains in a state of rest or uniform motion in a straight line unless it is compelled to change that state by an applied force. That is the statement of Newton's first law of motion. You have to learn or you have to by heart these statement because it is very much important. So I will tell once again. It states that an object remains in a state of rest or uniform motion in a straight line unless compelled to change that state by an applied force. In other words, it can be stated that all objects resist a change in their state of motion. That is, every body or every object continues to be in a state of rest or motion unless it is applied by an external force. Okay, as you may have, we can say that every body like to be tend to be in a state of rest unless if we apply an external force to that body, or every body will continue to move in a particular direction by the application of force unless we have to apply an opposing force to stop its motion. Otherwise it will continue, it will like to continue in a state of motion. Similarly, every body will continue to be remain at the state of rest if we not apply any external force. If we are applying an external force, the body will move in the direction of that external force. Okay, is it clear? That is, every body will continue to be, every body will like to continue to be in the state of rest or the state of uniform motion unless it is applied by an external force. Okay, the first law of motion is also known as the law of inertia. It's also known as the law of inertia. What is inertia? Inertia is a tendency of undisturbed objects to stay at rest or keep moving with the same velocity. That is, the tendency of any undisturbed objects to stay at rest or to keep moving with the same velocity is called inertia. Okay, That is, the body is like to remain in the same position. If it is rest, the body will like to be remain in the state of rest always. Or if the body is moving in a particular velocity, or with a particular velocity, says 5 meter per second, the body will like to move at the same velocity all the time. That is known as the inertia or inertia force. Okay, so this is the first law. There is a concept of first law of motion. We have to discuss one of the example. Let's go through that. That is, you may have come across this example in your life. If you are going to school in a bus, you may have definitely go through these what this example. Let's look into that. When we are standing in a bus and the bus begins to move suddenly, now we tend to fall backwards. This is because the sudden start of the bus brings motion to the bus as well as motion to our feet in contact with the floor of the bus. But the rest of our body opposes this motion because of inertia. That is, if we are standing in a bus and the bus suddenly start to move in forward direction, then we will lean backwards, or we will fall backwards due to the force of inertia. That is, our entire body will like to remain in the state of rest. That we are standing, the body will always like to remain in the state of that rest. But if the bus suddenly start to move quickly, the bus will move. Along with that, our feet is in contact with the floor of the bus. Our feet will also start to move along with the bus. But the rest of our body will try to remain in the same position, that is, remain in the rest. So, if the body is moved, if the bus is moving forward, our body will lean backward, or we will fall backwards. This is due to the motion of inertia or the inertia force. This is what the first law states. Okay, that is, object remains in the state of rest or uniform motion in a straight line unless it is compelled to change that state by an applied force. Okay, then we have to go to the second law of motion. Look at what it states. The second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. It states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Okay, the rate of change of momentum of an object is directly proportional to the applied unbalanced force in the direction of force. Okay, then we have to discuss what is momentum. Momentum of object is defined as a product of mass and velocity. Momentum is denoted by the small letter p, that is, p is equal to m into v, that is, m is mass and v is velocity. Momentum is the product of momentum of any particular object is the product of its mass and its velocity in which the body is moving. Clearly. So the second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of motion. That is, momentum is proportional to the applied force. Okay, what is momentum? We have discussed momentum is a product of mass and velocity. The momentum has both direction and magnitude. That is a vector quantity. That is, it has both direction and magnitude. And its direction is same as that of velocity. The velocity and direction are in the same direction. The unit of momentum is kilogram meter per second. Per kilogram meter second raised to -1. That's the unit of momentum. Kilogram meter per second. That is, the second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Okay, we will discuss some examples, so you have so you will clearly understand what the concept is. Okay, we have to discuss before going to the example. We have to discuss a mathematical concept of the second law of motion. Suppose an object of mass m is moving along a straight line with an initial velocity u. A particular object is considered and it has a mass m, and that mass m is moving in a straight line with an initial velocity u. Okay, then it is uniformly accelerated to a velocity v in time t by an application of constant force F. Okay, that is, if we are applying a constant force F, it is uniformly accelerated to the velocity v, that is final velocity is v, in time t seconds. Okay, then the initial and final momentum are P1 is equal to m into u and P2 is equal to m into v respectively, where P1 and P2 are the initial momentum and final momentum, m is the mass, u is initial velocity, and v is the final velocity of the object. That is, suppose an object of mass m is moving in a particular direction with an initial velocity u. If you are giving a constant force F throughout a time t, the body will be accelerated to a final velocity v in time t seconds. Okay, then its initial momentum and final momentum are p1 and p2. Okay, then then the change in momentum, we can calculate the rate change in momentum, that is p2 minus p1. And we know that P2 is equal to m into V, P1 is equal to m into U. Then P2 minus P1 is equal to mv minus mu. Then we will take m as a common factor. Then m into V minus U. This is a change in momentum. Then the rate of change of momentum is what the change of momentum in a particular time. That is the rate of change of momentum. Therefore, m into v minus u divided by t, that is, this is the rate of change of momentum. Okay, then according to the second law of motion, the rate of change of momentum is directly proportional to the applied force. That is, the second law of motion states that the rate of change of momentum is directly proportional to the applied force F. This is the rate of change of momentum and this is the applied force F. Then to remove the proportional, we will take the k, where k is the proportionality constant. Therefore, F is equal to k into m into v minus u by t, where v minus u by t is the rate of change of velocity. Okay, v minus u by t is the rate of change of velocity. And what is the rate of change of velocity? Acceleration. Okay, you know that distance, speed, distance, time, acceleration, etc. Okay, then the rate of change of velocity is known as acceleration. Now v minus u by t is the rate of change of velocity. V minus u by t is taken as a is the acceleration. Therefore, F is equal to k into m into a, where k is the proportionality constant, m is the mass of the object, and a is the final acceleration of that particular object. For an uniform force, this k will be tend to unity. Okay, for an uniform force, this k will tends to be unity. That the value of k will be 1. Okay, then finally we will get F is equal to m into a. This is the basic equation of second law of motion. That is, F is equal to ma. This is very important. You have to go through these equations in all of the coming or coming syllabus or coming portion. You will definitely go through the equation in your higher, in your 10th standard, 12th, 11th or standards. You will definitely go through the equation. You have to solve problems based on these equations and all that. So the second law is very important. You have to learn the equation, that is F is equal to m into a, that is force is equal to the product of mass and acceleration. This is the second law. Force is equal to the product of mass and acceleration. Clear? Okay, now we will go through an example of the second law. This, you may have experienced this before if you have ever played cricket. You are in 9th standard, you will definitely play cricket in your childhood. So you may have experienced this before. Okay, let's just discuss what is this. While catching a fast-moving cricket ball, a fielder in the ground gradually pulls his hand backwards with the moving ball. In doing so, the fielder increases the time during which the high velocity of the moving ball decreases to zero. Thus, the acceleration of ball is decreased, and therefore the impact of catching the fast moving ball is also reduced. If the ball is stopped suddenly, then its high velocity decreases to zero in a very short interval of time. Thus, the rate of change of momentum will be very large. Therefore, the large force would have applied for holding the catch that may hurt the palm or hand of the fielder. You can clearly see the picture what it says. That's if the fielder is trying to catch a ball which is coming downwards with a high velocity. If the fielder is holding the ball, holding his hand straight and try to catch the ball, a large amount of force will affect his palm or his fingers. It will affect or it will hurt the palm of the fielder because the rate of change of momentum will be very large. Because if he is trying to stop the ball suddenly, then the velocity decreases to zero in very short period of time. That the ball will uh, rest, or the ball will become the state of rest in a very short period of time. That is, the velocity is trying to the fielder is trying to stop the ball. The high velocity will decrease to zero in a very short period of time. That is, the rate of change of momentum during that period is very high, which may result in injury to the hand of the player. In order to reduce that, in order to uh, in order to stop this cause, the fielder have to lift his hand downwards while catching a ball. By doing so, he will gradually decrease the speed or the velocity of the ball, so he can catch the ball very easily without causing any injury to his hand or without slipping the ball from his hands. You may have seen, if you have watched cricket before, you may have seen if the fielder is trying to catch the ball will bounce out of his hand. Because the fielder is holding his hand simply like this, the ball will directly impact to his hand and it will bounce back due to the high velocity of the ball. But if the fielder is lowering his hand downwards, the rate of change of momentum will decrease slowly, so he can easily catch the ball. That is the concept of the second law. Okay, clear? Then we will go to the third law of motion. Is very easy. You may have heard it before. That is, for every action there is an equal and opposite reaction. You may have heard this before. For every action there is an equal and opposite reaction. That is a simple description of the third law of motion. That is, for every action there is an equal and opposite reaction. Okay, the clear definition of the third law of motion is that it states that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first. That is, it says that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first. That is, if you are giving, look, if you are giving a force like this to the second object will instantly exert a force back to the first. That is known as Newton's third law of motion. That is, if you are giving a force like this, the second object will give a force back to the first object. That is, for every action there is an equal and opposite reaction. Equal and opposite reaction, because if we are applying a 10 Newton of force like this, the another body will also exert a 10 Newton of force back to the first object in the opposite direction. That is, the first object is putting the direction like this or giving the force in this direction. The second object will give the force in opposite direction to that. But the magnitude of force will be same. If the first object is giving 5 Newton of force, the second object will give back the same 5 Newton of force, but the direction is opposite to that first force. Okay, that is for every action there is an equal and opposite reaction. These two opposing forces, the first force and second force, are known as action and reaction force. The first force is action, then the second force is reaction. Okay, clear. Third law states that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first. That is, for every action there is an equal and opposite reaction. One of the important examples is that it is a recoil of gun. You may have discussed it before. If not, we will discuss it in later chapter. What is a recoil of a gun? And you may have seen some Hollywood movies or Bollywood movies, and you may have seen that the hero or villain is firing a gun. If you are firing a gun, the bullet will exert a forward motion. During the same time, it will provide a backward motion to our hand. That motion is called recoil force of the gun. Look at the picture. If we are firing a bullet, the bullet will go like this. The acceleration of force of bullet will be like this. At the same time, the gun will exert a recoil force backwards to us. That is known as recoil force of the gun. For example, when a gun is fired, it exerts a forward force on the bullet. The bullet exerts an equal and opposite force on the gun. This results in the recoil force. That is, if we are firing like this, the bullet will go straight and the gun will exert a backward force towards the person who fired the gun. That is known as recoil force. That is, the bullet exerts a force, then the gun will receive an equal and opposite reaction. The direction of motion of that bullet is action, and direction of motion of that gun is reaction. Okay, clear? These are the three laws of motion. What is first law?